The action potential, represented here as a bright light, originates from the axon hillock on the cell body. Once initiated, the action potential travels unchanged all the way from the axon hillock to the axon terminus. Events responsible for this all-in-one propagation of the action potential occur along its membrane. Here, in cross-section of the axon membrane, we see the movement of sodium ions, shown as yellow spheres, into the cell as the action potential travels down the axon. As the action potential moves along the axon, brief changes in voltage across the membrane cause sodium channels, which are embedded in the axon, to open. Positive charged sodium ions then move from the outside to the inside of the cell. The positive sodium ions move inside the cell because they are attracted by its negative charge. After the action potential passes, the sodium channels close.
这个轴组的内跟外，它就是正负电的累积，然后它们透过这个物质的，就是一直换来换去，然后就会有电可以直接传导。好。我们再来看它更精致的一个影片讲解啊。
Conduction of nerve impulses relies upon the movement of electrically charged ions across the nerve cell membrane.
现在里面这个里面呢都是钠，外面都是钾。好，这里面的钠比钾多。
Sodium ions are actively kept out of the cell by an energy-consuming
主要这边里面刚开始的时候是负的比较多，外面是正的比较多。好。
When an impulse travels along the nerve, sodium ions flood into the
然后
cell
这条线是一个电位的曲线哈。如果钠往上移，然后钾往下移的时候，电位就会不平衡。它不平衡的时候，它就会产生。
Potassium ions leave the cell, restoring the negative charge within the cell and the positive charge outside.
那移动过之后，它会又回到原来的状况，就是钠又回来，钾又会出去，这样好。很短的影片哈，但是你们看一下，它用不同的方式来去做解说。
I've looked at the resting potential in a neuron that is not transmitting nerve signals. What happens when the cell is stimulated? A stimulus changes the permeability of the cell membrane to sodium and potassium ions. This alters the distribution of charge in the cell body, and if the change is great enough, it triggers a signal called an action potential that moves down the axon. How does the action potential move along the axon? Voltage-gated channels in the membrane open and close depending on voltage changes across the membrane. When no nerve signals are being transmitted, these channels are closed. A stimulus causes voltage-gated sodium channels to open, and sodium ions rush into the cell. The cell becomes positive on the inside and negative on the outside. Very quickly, the sodium channels close, while voltage-gated potassium channels open, allowing potassium ions to rapidly diffuse out. The cell returns to being positive on the outside and negative on the inside, and the potassium channels close. Meanwhile, the sodium ions inside the cell have diffused to adjacent areas, causing a slight change in the polarity of the membrane ahead of the action potential. This change in polarity causes the voltage-gated sodium channels along this part of the membrane to open. Again, sodium ions rush in, and the action potential spreads to the adjacent part of the neuron. In this way, the action potential travels down the neuron like a wave. In the wake of the action potential, potassium leaves the cell, restoring the negative charge inside the neuron. Meanwhile, the sodium-potassium pump has been shuttling sodium ions out and potassium ions in, re-establishing the resting potential distribution of sodium and potassium ions.
个是一个回控机制，
Let's look at another action potential as it moves
原
along
来的
the
样子
membrane.
休息电
This
位。
time we will measure the voltage changes that occur in one spot along the membrane. A slight change in polarity causes the voltage-gated sodium channels to open. Sodium ions rush in, causing a reversal in membrane
就说这
polarity.
里是正，这里是负，
Sodium
这里是
channels
正，这里
close
是负
and
的时候，
potassium
电位
channels
最高
open.
啊。
As potassium ions rush out, the membrane returns to
然
being
后它
negative
会
on
下
each
降，而且
side.
会
The
到
sodium
稍微负
potassium
一
pump
点，
then
然后
restores
再回
the
到休
balance
息
of
电位。
ions present at
这个
resting
是叫它
potential.
回到休息电位的机制。好，你们看这里，这里是多少数字？负70哈。所以在神经元里面的平衡电位其实是负70，不是0，好，是负70。负70是它的休息电位哈。好，那个在你们刚才补充的资料里面也有哈。好，那这个小短片呢，好。它是说明当口突触传送神经物质进来的时候，如何去累积那个电位，然后往下传。
As the action potential reaches the neuromuscular junction, vesicles containing acetylcholine fuse with the membrane of the nerve terminal, and acetylcholine is released into the cleft. Acetylcholine molecules rapidly diffuse across the cleft and bind to the acetylcholine receptors. Binding of acetylcholine to receptors immediately opens ion channels, allowing sodium ions to rush into the muscle fiber and potassium ions to diffuse out. Acetylcholine is then split to acetate and choline by cholinesterase, resulting in inactivation and closure
好，
of
这
the
些
channel.
物质被使用完之后就会被再回收回去。好，
The
那
initial
它
flux
进
of
来
ions
主
due
要
to
是在
opening the
开
channel
关这
the
个
membrane
gate，
potential of the
好，
threshold,
让那个
causing
物
the
质
voltage-gated
的
sodium channel
流
in
动，
the vicinity to
好，
open.
就是
The resulting
内外的
action
流动。
potential is propagated over the entire surface of the muscle,
然
and
后
also courses
到这
into
里
the
去累
T2
积一
system.
个主
As
要
the
的
action
足够量之
potential
后，当它要
returns
往
to
下
the
传，
receptors in the T2
产生
pole,
电位
it，causes
这个门
opening
就
of
会
the
打开。
ryanodine calcium channels of the lateral sacs, thus allowing calcium ions to diffuse out of the lateral sacs
就把一
and
些
into the
物质
region of the
先
myofibrils.
传送放到
Calcium
外
then
面
binds
来，
to troponin,
就是那个钠镁
resulting
钾。
in movement of the tropomyosin-troponin complex away from myosin binding sites on actin. The contraction process continues as long as action potentials continue to reach the neuromuscular junction, thereby keeping the concentration of calcium elevated around the myofibrils. To end the contraction, calcium must be actively transferred by the calcium pump, calcium ATPase, back into the lumen of the lateral sacs. This pump utilizes ATP as a source of energy. This process reduces the concentration of calcium in the vicinity of the myofibrils, such that calcium dissociates from troponin. Tropomyosin again covers myosin binding sites on actin, and the muscle relaxes.
好，所以神经电位它其实里面靠的就是各项离子的这样子的互通哈，产生的电位哈。好，好，有没有哪一个需要再看一次的？这样清楚就是说在我们课本上面提到的神经元的传导，可能都是会非常简化的方式来去跟同学做说明，好，但是透过这样子的一个影片的模拟，就比较清楚说，你看单一的神经元它的电位传导都已经是这么的复杂化，而且那个速度是很快的，啊，速度是很快的。好，接下来要请就是同学看的是有关于 PET 跟 MRI 的仪器，它可以做一些什么样的功能哈，然后怎么样子的操作哈，让同学看一下。
how to know that. Neuroscience is the scientific study of the structure and functions of the nervous system. In this film, we will be concentrating on the brain. These microscopic cells, neurons, are the building blocks of the brain and form a communication network. Rather than approaching neuroscience by looking at individual neurons, my colleagues, graduate students, and I, here at the Brain Mapping Center at UCLA, look at how assemblies of neurons work together to form functional units. We can measure the brain's electrical response and see how it unfolds over a time scale of milliseconds. Measurements of evoked electrical responses are called event-related.
这个他先讲的 ERP 是一个生理回馈，也是透过那个电极嘛去了解你各种不同的心跳、血压、呼吸这些。那这个是正子的那个电脑在程摄影啊。那这是讲它的原理啊，
which is a nuclear accelerator.
它是透过核子
Tomography refers to making a picture or tomograph of specific slices
作用，然后
The blood carries the
我们
radioactive
的
glucose
血液里
throughout the
面
body and into the brain.
会期待这样子的物
The
质，
colored areas show where there is more glucose
可以透过那个
metabolism
仪器，就是让它流动集中到某一个地方，
These
方
PET
便
scans
去
red
知道那个地方的
most
活动
glucose
情形。
metabolic activity.
这个是正常的
Yellow,
哈，
less. Green, even less.
因为我们用的视觉最多，所以通常这个地方的活动量会比较
to this
高。
one of a person with Alzheimer's disease, whose brain shows a dramatic decrease in the metabolism, indicating
这
widespread
应该谈的是
activity.
精神分裂症的患者。
Conversely,
你看他的活动，刚才我的活动是比较分散的。那这个是特别可以针对脑里面有没有到那个肿瘤啊，如果肿瘤就会出现白点这样。
F refers to
那这个是 MRI，
scan continuously, taking a complete picture about every 2 seconds. With the invention of very
MRI 的
MRI
摄影照起来就是它可以是
it is
每
now
一个
possible to take a picture
层面每一个层面的去照，所以一整颗脑做剖面，你可以照到640张图啊。你甚至可以透过这样的图去做3D 的重建你的大脑。那这里谈的是说，这个小孩子在看这些图片的时候，对，那他的大脑的这个活动都可以被测得到。
daily basis, enabling us to probe and thus better understand the human brain. As the technology improves, we'll be able to explore the brain in much greater detail and use this knowledge to better understand brain disorders, to visualize the effect of interventions on the brain, and to tailor treatment strategies based on this knowledge.
好，那这后面这一段是讲说，这样的技术可以让我们更精确的去了解大脑里面的功能跟状况。如果我们善用这样的技术的话，就是非常的有帮助。好。